Hi, this is Mr. Ward, and I'm going to do another video on a few selected questions that were requested on the MCAS. So first I need to make a couple of adjustments. Okay, I'm back and I've made a few adjustments. I'm going to go ahead and do this in Cami because I like the drawing tool a little better than what Screencastify has given me. So we're going to start with number 10 from the 2019 test. And number 10 involves the angle relationships in parallel lines. If you cut a parallel lines with a line that goes through them called a transversal, there are special angle relationships. We are trying to figure out what the measure of this angle, angle 2, is. We've been told what angle 1 is, and that will give us a pathway to find angle 2. So the first thing to get is that if you have two parallel lines that are cut by a transversal, there is a pattern of angles that are all the same. So that those two angles are, of course, the same because they're called vertical angles. They are the opposites at an intersection. However, this angle is congruent to angle 1 as a corresponding angle. You could think of it as kind of a rhyming angle with angle 1. And then because this angle here is opposite of an angle, this angle that was congruent to 1, it is also congruent. So this is a vertical angle to the corresponding angle to angle 1, and this is a vertical angle to 1. And you might notice we get this sort of zigzag pattern of congruency. Now, once we know that those angles are all the same, we now know that this angle next to angle 2, or this angle next to angle 2, is 120. So if this is 120, okay, and admittedly I am terrible at drawing letters on a screen, that's 120. This whole thing, which includes angle 2, needs to be 180. So angle 2 is going to be 180 minus 120 equals angle 2. So that equals 60 degrees. Okay, and so that's the measure of angle 2. So our answer is B. So we're back right here. So our answer is B, 60 degrees. Okay, so angle 2, by the way, and I'm just going to mark this up so if you needed to know, angle 2, of course, is congruent, creates a zigzag pattern here. These are all congruent to angle 2. All right, I'm going to pause and head down to the next set. Okay, I was also asked to talk about number 11. So number 11 is a Pythagorean theorem question. So because this is a right angle, what we can now apply is, of course, that's a Q, A squared plus B squared equals C squared. Now we are given one of the sides. We're told one of the sides is, I guess I have to stretch it out this way. There we go. And we are given one of the sides is 6 inches. Now, this is not the hypotenuse. The hypotenuse is the long side. It's the side that's opposite the right angle. So I'm going to label things. So we'll call this C for sure. This one could be A or B. I'll go ahead and call it A. Okay, A equals 6. And then we've got B. So if you look at the options, what you want to do is you want to look at the shorter side as B, okay, and the longest one as C. So you can look at 6 squared. That 6 squared is going to be 36. So 6 squared will be 36. Okay, so that's 6 squared is 36. 2 squared would be 4. Okay, and then 8 squared would be 64. 36 plus 4 does not equal 64. So that is not a side relationship that works for this. Okay. 8 squared is 64, so we know that's 64. So if we rewrite that as 64, cross this out, and do a 10 squared, that's 100. Does that side relationship work? 36, which is 6 squared, plus 8 squared, which is 64. Does that add up to 100? It does. So this is our choice. Now, there's a shortcut on this one. If you happen to know about what are called Pythagorean triples, you might notice that 6, 8, 10 can be scaled down to 3, 4, 5. And 3, 4, 5 is a very famous Pythagorean triple right triangle because 3 squared plus 4 squared is 9 plus 16, and 9 plus 16 equals 25, which is 5 squared. And that will always make a right triangle. And any of the scaled up or scaled down versions, 6, 8, 10, 9, 12, 15, let's see, 3 times 5, so 15, 4 times 5, 20, and 5 times 5, 25. So a 15, 20, 25 triangle is a Pythagorean triple as well. So there are other Pythagorean triples you'll run into here. There's the 5, 12, 13 triangle is a Pythagorean triple. You might run into 7, 24, 25. So there's a bunch of them that would be useful to be familiar with. Once we've found B, we don't need to worry about the others, but if you wanted to test it out, 36 plus 64 is not the square of 14, which is 196. We already know it's 100. And 36 squared, 6 squared, which is 36 plus 10 squared, would be 136. And 136 is not equal to 14 squared, which again is 196. Now let's talk about number 13, which is very similar to number 10. Number 13 is asking about all the angles that are congruent to angle X. So once again, I'm going to go ahead and identify that zigzag pattern. So that's angle X. The angle right across from it, called a vertical angle, is congruent to it. If these two lines are parallel, then angle 4 is also congruent to it. This is called a corresponding angle. Angle 4 and angle 3 are known as alternate interior angles, and they are, as you can see, congruent. And then angle 7 is congruent. So if you just know that the opposite angle is congruent and that the corresponding angles are congruent, then you'll also be able to find that this opposite angle is congruent. So once again, we get that zigzag pattern. So zigzag pattern of congruency. I'll just remind you what congruent means. Congruent means the same in all measure. So angle 1 is no. Angle 2 is no. Angle 3 is yes. Angle 4 is yes, because it's corresponding. Angle 5 is no. Angle 6 is no. And angle 7 is yes. All right, I will add one more thing. Angle 5, angle 6, angle 1, and angle 2, each of those are supplementary to angle X. That means that if you knew what angle X was, you could find angle 1 because angle X and angle 1 add up to 180 degrees. Supplementary, think it makes a straight angle, which is 180 degrees. A related concept is complementary, which adds up to a corner or 90 degrees. And that's the video for right now. I hope it was helpful.